Number sense, problem 3. There are two positive whole numbers, and their difference is 21. The greatest common divisor added together with their least common multiple is 287. What is the value of these two numbers? So let's say that these two positive whole numbers are A and B. And let's say that A is bigger than B. So if we subtract B from A, we're going to get 21. And they have a greatest common factor. So let's say that greatest common factor is M. So A would be M times lowercase a, and B would be M times lowercase b. MA equals the capitalized A, and MB equals the capitalized B. So if we subtract MB from MA, we're going to get 21. And then it says the greatest common factor, M, added together with their least common multiple is 287. How can we represent A and B's least common multiple? Well, we can do MA, that's representing A, and we can multiply a lowercase b onto it, because in this term, there's also M times B, and that equals 287. So now let's group these two equations together. We're going to have to find out the values of M lowercase a and lowercase b. But right now we can't get anything out of these two equations. In equation number 1, I see that we can use the distributive property to factor out the M. We can do M times the difference of A and B, which would give us 21. And in equation number 2, we can do the same thing. We can factor out M. That gives us M times the sum of 1 and AB, $287. Look at each group of parentheses as a whole. So M times something equals 21. And so M is a factor of 21. Now let's list out the factor pairs of 21. We have 1 in 21 and 3 with 7. So M can either be 1, 21, 3, or 7. We've narrowed it down to 4 possibilities. We might be able to do 1. And what about 21? If M was 21, then A minus B would have to be 1. And M over here in this equation too has to be 21 also. But 287 is not a multiple of 21. So M can't be 21. If M was 3, then A minus B would have to be 7, and the M over here has to be a 3 too. But 287 is not a multiple of 3, so we can't do M equals 3. What about 7? If M was 7, then A minus B has to be 3, and 1 plus AB would have to be 41. Maybe 7 could work. Now let's try out M equals 1. If M equals 1, then A minus B has to be 21. And 1 plus AB has to be 287. And so AB themselves, without the plus 1, would be 286. So now here are the factor pairs of 286. We have 1 and 286 itself, 2 and 143, 11 and 26, 13 and 22. But remember, over here in the first equation, a minus b has to equal 21. 286 minus 1 does not equal 21. 143 minus 2 does not equal 21. 26 minus 11 does not equal 21. And so doesn't 22 and 13. So now we know that m has to be 7 because m equals 1 does not work. If m was 7, then this parentheses would have to be 41. And AB equals 40. What are the factor pairs of 40? We have 1 and 40, 2 and 20, 4 and 10, and 8 with 5. Now if m equals 7, then over here this a minus b has to equal 3. So which of these factor pairs differences is 3? 40 minus 1 does not equal 3. 20 minus 2 does not equal 3. 10 minus 4 does not equal 3. So 8 minus 5 equals 3. But remember, we're not done yet. We know what these are. A is bigger, so it's 8. And B is smaller, so it's 5. But what we're really trying to find is A and B, all capitalized. So we know that this capitalized A is m times lowercase a, which is 7 times 8, 56. And capitalized B is 5 times 7, which is 35. The value of these two numbers is 56 and 35.